Yes, class, am I audible to all of you?
Yes, ma'am.
Okay, so who all have joined? Ali, Alina, Jyopita, Jesleen, Sabiha, Zainab. Laika, are you not able to rename?
Yes, ma'am, I've renamed. Sorry.
Okay. Okay. Okay, so as I've told you, some of you have already completed this chapter in detail, and we are going to do the thing again. So you have to be interactive and you have to be responsive. If you're not well with this chapter, then we'll go one step back again. We'll again start with laws of motion. Some of you are there who haven't done this chapter with me presently. So for them, it will be fresh. But for all those who have done this, it will be a revision class for them. Zainab, no, you waited. Because if something is additional, which you have not done, that you can write. Otherwise, exact same thing, no need. But questions you have to solve again. That's why I'm having this class with you all. Okay. Questions you have to write it again. So what basically this chapter is work, energy, and power. So whatever concepts you have studied till the fourth chapter are applied in this chapter. So this is about work, energy, and power. So firstly, we'll have the concept of work done. We'll get a good command on this portion. And once work done is over, then we'll come to energy and then power. Work done is a very short and small topic. That's why all of you should be clear with work done at least. Okay, we have stopped at the center of mass. So all of you should be perfect in this chapter now when we are doing it. So basically, work done means there has to be a displacement, and whatever is the displacement produced due to the particular force, we multiply it. And multiplication in which manner? We take the dot product. So dot product of force and displacement gives us the work done. So if you are sitting and you are working continuously day and night, and let's assume you've worked for 14 hours and you're just sitting in front of the laptop and you're working, but still in physics we will say you have not done any work because you haven't moved. There is no displacement is zero. So physics, in terms of physics, we will say there is no work done. The literary meaning of work done and the physical meaning of work done both are different. So in physics, we have a different definition of work done. In normal English literature, we have a different meaning of work done. Even if you're working for hours and you're not moving, there isn't any displacement produced due to the muscular forces which you are exhibiting or your body is exhibiting. There is no work done. So work done's formula is very simple. Work done is equal to F dot S. So force is a vector quantity, displacement is a vector quantity, but we have studied in dot product that dot product always gives us the scalar quantity. So if we are using dot product here, so we should know that work done will be, though it is the dot product of force and displacement, this will be giving us the scalar quantity. Means work done is a scalar quantity. So when you expand it, work done is equal to Fs cos theta. Okay, so it's a scalar quantity. Yes, Jesleen, what's the SI unit of work done? Yes, Jesleen, what's the unit of work done? Joules, very good. So SI unit is joules. We write it as capital J. And yes, what's the CGS unit? Jesleen, completed. SI unit you have told. Tell us the CGS unit also. Dyne, is it dyne? It's what? 1 joule is equal to dash ergs. Very good. not dyne. Dyne is for force. Correct. So 1 joule is equal to 10 to the power 7 ergs. This question comes from your units and dimensions. 1 joule is equal to 10 to the power 7. So erg is the unit. Very, very easy question this is. All of you will give the answer. And this question, all of you will give for those who, for whom this chapter is new. And the students who have done this, they have to give the answer anyways. Write it down, those who have not written it. And those who have the notes, they can avoid it. They can just keep on adding things. But the numericals part, you all have. Write it. Alina, Ali, Abir, write it. Yes, correct. So Zainab and Abir have answered. See, force here which is given, this is 10 Newton and it gets displaced by 5 meters. So if the force acts at 60 degree to the displacement, you have to calculate the work done. So work done is equal to force into displacement, right? So force displacement cos 60 degree. So force is 10. Okay, Jobita. Okay, then. No issue. 10 into 5 and then now class, one more thing, whenever you're having the values in SI unit, so you also have to answer it in SI unit itself. Okay, so yes, so this is 25 joules. Okay, one more question. Okay, you have to find out the displacement here. Quickly write this, then I'll discuss. Okay, let me discuss the next one. See, in this, you have the force given, because many of you, if you're saying you weren't there, then let's discuss this question properly. I think Zainab and Jesleen were there during the class. Sabiha, I don't remember. Sabiha, were you present? Because you were initially having the network issue. So let me know if you were present or not. Otherwise, I'll ask you in that manner. Like Jobita was absent, so I won't ask you. Now, see, force is equal to 2I cap plus 3J cap plus 5K cap. Now you have 2 points A where 3 comma 2 comma 1 is given. You have another point B where 2 comma 1 is given. Now first you have to find out the displacement, right? R, A, B. You have to first find out the displacement. So before that, you should know what are these points exactly. RA can be written as, see, this is X, Y, Z, correct? This is also X, Y, Z. So this becomes 3I cap plus 2J cap plus K cap. And RB becomes, this will be 2I cap plus J cap plus K cap. Now you have to find out their displacement. So RAB will be equal to RB minus RA, final minus initial. So what is this? Position vector finally equal to 2I cap plus J cap plus K cap minus this is 3I cap plus 2J cap plus K cap. So here the position vector are 2I cap minus 3I cap. This is minus I cap. J cap minus 2J cap. We multiply this minus sign first. So J cap minus 2J cap becomes minus J cap, and K cap minus K cap gets cancelled. Okay, Zainab has answered. Other students also, Sabiha and Jesleen, at least you all answer. Now, what is the value of force? 2I cap plus 3J cap plus 5K cap. 2I cap plus 3J cap plus 5K cap. So you have the force now, you have the displacement. So work done has to be calculated. So work done will be F dot R. That is force is 2I cap plus 3J cap plus 5K cap. Here dot is minus I cap minus J cap, right? Minus I cap minus J cap. So when you are multiplying, this becomes 2 into minus 1, minus 2. This is plus 3 into minus 1 is minus 3. Correct, minus 5 joules. Very good, Sana. Write it down, all of you. One more question you all can solve. Okay, see now this is the force which is given, and now the force is variable. You can see it is 3x square plus 2x. Zainab and Jesleen should answer this question. This is a very simple question for you all. Rest of you here. See, when you are calculating, and Zainab, when you are leaving, just inform me and text me. So work done when you have a variable force, you write it as f dx. Now you integrate it from x1 to x2. That's how we use this formula, not the dot product formula, because our force is variable, right? Force is variable. So work done is equal to 3x squared plus 2x dx. So this is from 0 to 2. Let's write it individually. 3x square dx from 0 to 3 plus 2x dx from 0 to not 3, sorry, 2. So this is 3x cubed by 3 from 0 to 2 plus 2x square by 2 from 0 to. So this gets cancelled. So this is 2 cube minus 0 cube plus 2 square minus 8 plus 12. Write it. Correct. Shaima, not Newton, joules.
Ma'am,
Yes, say.
ma'am, how we got 8 here?
What are you saying, Jobita?
8.
It's okay. This is two. Here you're saying
Yes, ma'am. Is it 2 square or 3 square?
this is x to the power 3, right?
Yes.
So when you put 2 here, it becomes 2 to the power 3.
Okay, ma'am.
Okay. Okay, and now when we're talking about the graphical method, the area of force versus displacement graph will give you the work done. Okay, now see class, there's a logic whenever you are solving anything through graphical method. Firstly, remember, when you are getting the slope, so you divide the quantities. This is how you get, like when you want velocity, you are dividing displacement by time. So velocity is given through the slope, that is tan theta. And that's what we have been doing. Now, when we are talking about the area under the graph, so for area under the graph, basically the two quantities should be multiplying to each other. So quantities should multiply. Like for distance, if you're getting, it is velocity into time. So displacement will be given by area under the VT graph, like this. So likewise here, if we are getting the area of Fs, so it is obviously very clear that force and displacement will be multiplied. And if you take it opposite manner, like force and displacement are being multiplied, so we'll get the third quantity through area, not the slope. So this is a little important. So area above the displacement axis is taken positive and below the displacement axis is taken as negative. So one question, all of you will answer. That will complete our work done. Write it quickly. No, no, Shaima, no. Whatever questions we are doing, just the questions again, not the notes part, because you already have them. There is no point of writing it again. If there is anything which I'm writing additional, which you have not written it, because you've joined late, this actually I've discussed before with Zainab and other students. So no need to copy it. Why would you copy it? It's just a repetition, but questions you need to copy it again. Because this entire session for you all is to practice the questions and which you were lacking in, right? So if anything is additional, which I have not mentioned during your time, that you can mention, otherwise no need. Yes, so Shaima Zainab, correct. Other students also, this question at least you can solve. See, this says it's a rectangle given and you have a triangle which is given. So if rectangle and triangle are mentioned, then how will you calculate? Simply, you will see what is above, what is below. So positive and negative, right? Now, area, the total work done here will be equal to the area of the rectangle plus the area of the triangle. Area of the rectangle is simply 3 into 2 plus this is half into base is 2, height is minus 4. No, this is height is also minus. So this will be cancelled. So 3 into 2 will be 6. 6 minus 2. So correct. It's 4. All those who have not written, write it. Okay, so work done is completed. So any doubts in work done by anyone? Those who were not present in that class, those who are for those whom the chapter is new, and for those who have already done it and they are doing it for the second time. So any doubts? Work done is completed. Energy, let me start. Now, if you have any doubts, anyone who has completed or who is doing it twice, you can ask. I'm starting with energy because energy is a little portion. You already know that energy will take a little time than work done. Work done is easier. Work done is completed. We'll discuss energy in whatever time is left today. In the next class, we'll try to complete the energy. That is tomorrow. We'll try to complete the entire topic of this energy. So that one more class for power and wrapping this lesson. Okay, and collision is needed. So after that, we'll then go back to rotation. So what is mechanical energy? Mechanical energy is basically the total energy. So you have two types of energies in your syllabus. It doesn't mean there are only these two types of energies only. You don't just have kinetic and potential energies. If we are saying mechanical energy is the sum of all the energies, it means all of the energies which are present, whether it's internal energy, whether it's entropy or any other energy which is present. So mechanical energy is basically the sum of kinetic and potential energy. So mechanical energy, it's the sum of kinetic energy plus the potential energy. Now let's start with kinetic energy. We have time. We can, I think, complete a bit portion of kinetic energy. So kinetic energy is the energy possessed by a body due to its motion. Means when the body will move, when there will be a movement produced, when the body will be having a certain initial velocity or a final velocity, in those cases we will get a kinetic energy. So kinetic energy comes into action as soon as the body comes into its state of motion from the state of rest, because there will be a work done when the body was in the state of rest to when the body is going back to the state of motion. So this change in the work done gets stored in the form of potential energy, where we have this concept and a very, very important theorem, which we say work energy theorem. Work energy theorem. So work energy theorem basically says that whatever is the work done, that is your force into displacement. Whatever is the work done, it gets stored in the form of kinetic energy. And how do you calculate kinetic energy? If there are two values of kinetic energies, then you take the difference, final minus initial. This is how you write. So final kinetic energy minus initial kinetic energy. So it means the work done also gets stored in this form. That is the final kinetic energy minus initial kinetic energy will give you the work done. So what is work energy theorem? Work energy theorem is basically the work done, or you can say the work which is done, work done is equal to the change in kinetic energy. It's equal to the change in kinetic energy. This is the definition of work energy theorem. So this says that the work done is equal to the change in kinetic energy. Can be said as change in kinetic energy. Yes, work done gets stored in the form of kinetic energy. So it is change in kinetic energy only. Yes, correct, Zainab. So work done is equal to a change in kinetic energy. So we say work done, it's equal to the change in kinetic energy. And kinetic energy is not negative. Kinetic energy is a scalar quantity. So work done is also not negative. Work done is also not a vector quantity, it's a scalar quantity. That is, you can say kinetic energy final minus kinetic energy initial. It's a very important theorem, work energy theorem. This theorem, this is very important, and this has a lot of application in your this chapter and the upcoming chapters, even in rotation, even in gravitation, even in your bulk properties of matter. When we come to book 2, there you will see work energy theorem has a lot of significance. So a small derivation, let's do it, then this portion will be done. So energy possessed by a body due to its motion is called the kinetic energy. So kinetic energy is written as half mv square. This is the formula of kinetic energy. This is the formula of kinetic energy, half mv square. So suppose there's a block of mass m. There's a force which is exerted on this block m, and it has been accelerated to up to acceleration a. Then the block covers a certain displacement, that is from x1 to x2 it moves. So x2 is the final stop. Now there will be a final velocity. So initially it was v1, now it is v2. The body has stopped. So during this entire duration, there is a displacement covered, so there is a work done. And we have studied if there is a work done. If work is being done, then you have concept of kinetic energy. Even without that, there is a movement. So you say, yes, there is a kinetic energy which is involved. So here you say work done is equal to force into displacement from x1 to x2. Now you know one thing, force is equal to mass into acceleration. So let's put that. So work done is equal to mass into acceleration dot dx from x1 to x2. Now we have to break acceleration. Acceleration can be written as dv over dt. But if we put dv over dt, it will again not make a significance. dv, velocity by time. Velocity by time cannot be solved in this. We cannot solve velocity by time. So if you write, see, velocity is distance by time. Double differentiation, double integration you can write. But let us leave it at this step first. Let's write dv over dt. You will see how can we change it. Okay. If you double differentiated, the issue that arises here is in the denominator. And when you are using the integration, so if you put it here, this will be mass dv over dt into dx from x1 to x2. As soon as you notice that in your equation there is this dx over dt, this dx over dt is equal to the velocity, immediately your integrals also change. So this is mv dv from v1 to v2 now. Clear? From v1 to v2. Now, m is taken out. This is v square by 2 from v1 to v2. Put it back. So this is equal to m v2 square minus v1 square by 2. So this is what? What were we calculating? This was the work done. Work done gets stored in the form of kinetic energy. So what is the kinetic energy? Half m v2 square minus half m v1 square. So what is the change in kinetic energy? Final kinetic energy minus initial kinetic energy. And what was it equal to? The work done. So this is actually a derivation. This is a derivation for work energy theorem. For work energy theorem. Write it in here. Any doubts? I'm here. Let me. Because see, like now we have replaced initially this was our integral, and because of this dx we were having x1 to x2. Now we have changed this with the help of this denominator to the single v. Now no more this x1, these x1 and x2s are valid as integral. When we are integrating it, these have to be matched. So automatically this is v1 to v2, not x1 to x2. At this step, had we stopped, we would have done something else, then x1 and x2 would have left. Okay. See, when you're calculating the change in momentum due to kinetic energy, you should know one more formula of kinetic energy. This is P square divided by 2m. What is P? P is the momentum and m is the mass. How can we say this? See, kinetic energy, we have studied it as half mv square. So multiply it and divide it by mass. So this is half m square v square by m. You know momentum is m into v. So square of momentum will be m square v square. So when you replace this term with the momentum p square, you get kinetic energy is equal to p square by 2m. So there is always a question where there's a percentage change in momentum and kinetic energy. Write it for those who are doing it for the first time, and those who have done it, tell me the answer for this.